Morning, sixth grade. Got your quiz done. Power Up went back to the first weeks of school for you with a little multiplication. See how you did. 72, 16, 100, 18, 8, 25, 81, 24, 54, 21. Next row, 27, 30, 0, 42, 64, 28, 15, 63, 4, 48. Third row, 49, 12, 12, 40, 16, 6, 0, 32, 36, 18. Last row, 24, 20, 1, 14, 45, 56, 9, 36, 10, 35. If you want some extra credit on your power up here, I said one of the answers wrong. Circle the one that I said wrong. The mental math would read something like this. I subtracted, I got $5.50. I multiplied, I got $2.40. I multiplied by 6 on the bottom, so I multiply by 6 on the top and I get 18. I reduced by dividing by 8 gives me 2/3. Square root of 36 is 6, square root of 49 is 7. 6 times 7 is 42. Divide by my denominator, 12. Multiply by my numerator, 24. Estimate the difference. Difference means subtract. So I rounded 126 to 130. I rounded 45 to 50. And I did 130 minus 50 is 80. If you rounded 126 to 100 and 45 to 50, then you would got an answer of 50. I would definitely have allowed that, guys, because when we think estimating, lots of times we think just that first digit. Obviously, 80 would be much closer to the real answer than 50, but I would have allowed it if you did 100 minus 50 is 50. It says square the number of sides of a pentagon. Pentagon is 5, squared is 25. Double that number, 50. Minus 1, 49. Square root that, 7. Times 4, 28. Minus 1, 27. Divide by 3, 9. Square root that thing, 3. Terrence folded a square piece of paper in half diagonally to form a triangle. He folded the triangle in half 2 more times as shown below. So folded, folded, folded. Then he used scissors to cut off the lower right angle of the resulting triangle. Which of the diagrams will the paper look like when it is unfolded? So after I fold that back out, will I have 4 squares missing in the middle? Will I have 4 squares missing on the outside? Will I have a fancy looking X, or will I have a big square missing in the middle? Now guys, what they're trying to teach you is, can you visualize that all in your head? If you can, rock on. Hopefully you got the right answer. If you can't, you might have had to do what I did, which is get this for a thing. Yes, ma'am?
I'm sorry, are you recording?
Yes, it's all right.
Do you want milk at all?
Sure.
Okay, there's like half a crate or whatever down here.
You got it.
Mix of chocolate and white.
Thank you.
Thank you so much.
Yep. Okay, 6, sorry for the interruption, it happens sometimes. So I took a piece of paper, I folded it again, I cut the triangle just like I did, I unfolded it, and now I know my answer is the third choice there. So sometimes you can see it, sometimes you couldn't. Do what's necessary. Guys, we're moving on today. We're once again going to talk about decimal numbers. Yesterday we were working on comparing and rounding those things. On Monday we were learning about reading them. Today we're going to talk about them on a number line. I think the number line is easier than a normal number line. We've already worked on a number line with fractions. When we have fractions, I got to count all the spaces, and then I got to count all the tick marks to get my answer, and it can vary. With a decimal number line, it can vary. It's always chopped into tenths or hundredths or thousands. It just keeps getting smaller, but it's by the power of 10. So it reads like this. If the distance between consecutive whole numbers on a number line is divided by a tick marks into 10 equal units, then numbers corresponding to these marks can be named using decimal numbers with a decimal place. If each centimeter on a centimeter scale is divided into 10 equal parts, then each part is 1 millimeter long. Each part is also 1/10 of a centimeter. So it says find the length of it in centimeters and in millimeters, and they have it marked out for you. Now guys, what I did is I started counting, and I had 1, 2, and then I count those little ticks, and I got to 3. So as a centimeters, that's 2.3 centimeters. As millimeters, it's just times 10. Times 10 slides that decimal to the right once. It's 23 millimeters. Okay, don't ever switch a number. It's always the same numbers. We just slide that decimal point as we go through that. Hopefully you got that answer. Make sure you're writing those things on the back side of your quiz. Paragraph in between. If the distance between consecutive whole numbers on a number line is divided into 100 equal units, then numbers corresponding to the marks on the number line can be named using 2 decimal places. For instance, a meter is 100 centimeters, so each centimeter of the segment of a meter stick is 1/100th the length of a meter stick. This means that an object 25 centimeters long is 0.25 or 25 hundredths of a meter long. Find the perimeter of this rectangle in meters. Now guys, in the future as we're doing these problems, make sure you read correctly, because so often it says find that perimeter in meters, and what do? I take 12 plus 7, get 19, double it like I'm supposed to, get my answer, problem solved, and I forget that we're working with centimeters, but they asked me for the answer in meters. So it's all about when you want to change it. You could change it before you add it together and double it, or after. I'm going to leave it as whole numbers at the beginning here, guys. So I'm going to go back to what I said. I'm going to do 12 plus 7 gives me 19. I'm going to take it times 2 because there's a 12 here and a 7 there. That gives me an 18. Carry that, gives me a 38. Now, that's 38 centimeters. How do I switch that to meters? I divide it by 100. Centi means 100. I'm going from a smaller unit to a bigger unit. I need less of them. 1, 2 decimal point. So my answer is 0.38 meters. So make sure you're looking at the labels. That's how we make math one step more difficult, or one more step to do, by switching the measurements on you. Example number 3 says find the number on the number line indicated by each arrow. Now guys, they already have this divided into tenths, which means all those little ticks are dividing it into hundredths. And so the first thing I do is start counting 1, 2, 3, 4, 5. So that's my hundredths. So A is at 4.05. B would be backwards to, I didn't put all the tick marks in here, guys. You would be counting this way: 1, 2, 3, 4, 5, 6, 7, 8. So I would be at B, which would be 4.3. 1, 2, 3, 4, 5, 6, 7, 8. C would be 4.7123, so would be 4.71233. Okay, so you got your answers there, guys. The biggest thing is to understand you are already dividing the tenths. Now you're dividing into hundredths at another decimal place. Some of us like to say this is 4.5. And then we just start all over and we get really confused there. Make sure you add that decimal place to it. And last but not least, for your examples, number 4, arrange these numbers in order from least to greatest. Now the reason they gave us this one, guys, you did it yesterday. The reason they're giving us again today is saying, hey, think about this, you can use this on a number line. If I was a 6th grader, I'd bump to what I learned yesterday. I'd make all the decimal places the same amount. And I'd say, which one's the smallest? 25 is the smallest, so 4.25 goes first. Which one's next? 450. Now that's just 4.5 because I added that 0. Then the last one would be 4.81, or said correctly, 4 81/100ths. So you could use a number line, you could use the 0 trick we used yesterday, but we can also put those things in order as we work our way through that. Okay, couple quick review, guys. Millimeters to centimeters times 10, we're going to use that one a lot this year. And then this will be the other big thing we do, where we give you measurements in centimeters and ask you to switch it to meters, or we give you measurements in meters and ask you to give the answers in centimeters. We'll do that a lot this year. And then every once in a while they sneak this one in, guys. And I don't want to say sneak like it's a bad thing, but make sure you're adding another decimal place and don't get tripped up on that. All right, let's get set to do some math problems. 6th grade, here we get rolling. The first problem we're doing is number 3. It says Gina spent $3.95 for lunch. She had $12.55 left. How much did she have before she went in there? So I'm trying to figure out the total I started with. I'm just going to add those two together. I had $12.55. I had spent $3.95. I added together 15,161. She started with $16.50. Number 5, the perimeter of the square equals the perimeter of the regular hexagon. If each side of the hexagon is 6 inches long. How long is each side of the square? So we've been working these a couple of times this week. This is just going to get one step farther. I have a hexagon. It says each side is 6 inches long. So I take 6 times 6. That tells me the perimeter of the hexagon is 36. Now I want to say, well, then how long is one side of a square? A square has 4 sides, so I divide by 4, and I get 9 inches. So earlier this week, they had those things touched together. Now they separated them apart to make it go the next step. Number 6, in the following diagram statement, write the percent as a reduced fraction, then diagram the statement and answer questions. Each week, Jessica earns $12 doing yard work. She saves 40% of the money she makes. How much money does she make? Okay, so step 1, we start with 40%. That means out of 100. Chop off a 0, divide by 2, gives me 2/5. Now I'm taking 2/5 into $12. So that looks like this, $12 divided by 5, goes in there 2, 10, subtract, 0, decimal straight up, 4, 20, 0, bring down the last 0, goes in there, and then I gotta take that times the 2. So 2 times 0 is 0, 2 times 4 is 8, 2 times 2 is 4. She makes $4.80 is what she saves. That means question B, how much does she spend? I take my $12 and I subtract $4.80 from it. 2, 7. She spends $7.20. Number 8. Round to the nearest thousandth. The number is 7.49362. Tenths, hundredths, thousandths is the 3. I look to the 6, it rounds it up. Everything else in front stays the same. So it's 7.49, rounds up to 4. Everything else turns to a 0 and gets chopped off. Number 10. Use digits to write these decimal numbers. 175 million. So the first thing, guys, is I write 175. Millions, 100,000s, 10,000s, thousandths, hundredths, tenths, decimal point 0. Okay. 10B, 3,030 and 3 hundredths. So 3,030 and is a decimal point. 3 in the hundredths, I need a 0 in the tenths. So chop it in half before and after the decimal point. Make sure you get those. That's good practice of being able to read the words to get the decimal numbers. They're going to give that to us quite a bit. That's a challenge. Number 12 from today's lesson. Find the length in centimeters and then in millimeters. So I got my ruler there, guys. I'm counting all those tick marks after the 2, 1, 2, 3, 4, 5, 6, 7. So that would be 2.7 centimeters and 27 millimeters. So just count those tick marks carefully because they're really close together. Number 13, what decimal number names the point marked X? So guys, they gave me 8.2. They gave me 8.3 down here. I start counting tick marks. 1, 2, 3, 4, 5. So that 5 is added on. It's 8.25. Kind of a practice from example number, I think it was 3 today that we had on ours. Number 14. The coordinates of 3 vertices of a square are 0, 0, 0, 3, 3, 3. Draw a coordinate plane, plot the points on the coordinates given, and then draw the square. So I have 0, 0. I have 0, 1, 2, 3. I have 1, 2, 3, and up 3. Okay, so now it says draw this square in, so I got to come down and draw a square. So I need this point right there. That would be B. What are the coordinates for the fourth thing? That's over 3, up nowhere. So 3, 3, that's B. C says, what's the area? I'm just going to count this one. 1, 2, 3. 3 times 3 is 9. Square units. That's the numbers, letter C. Okay, so guys, sometimes I know we do the subtraction. That's always an option. Sometimes I just count. It depends on how big it is and if it's on a straight line. When it's on an easy little line like that, I'm just going to count. Number 15 says, what decimal number is halfway between 7 and 8? Well, halfway between 7 and 8, guys, is 7.5. That's 7.5. What number is halfway between 0.7 and 0.8? That's 0.75. So they're just seeing, can you make this transition from whole numbers to decimal numbers as you get that problem. Flipping my answer key over, I got number 20. I have 5 and 1/6 minus 1 and 2/3. Step 1, common denominators. This one stays the same. This one I took times 2 over 2. Gives me 1 and 4/6. Now I can't do that subtraction, so I have to cross out the 5, make it a 4. Bring over the whole 6 adds together, gives 7/6. Now I subtract. 7 minus 4 is 3/6. 4 minus 1 is 3, and that reduces to 3 1/2. 21, multiplication. I have 1/10 times 2 times 3 is 6, plus 2 is 8/3, times 3 times 4 is 12, plus 3 is 15/4. I'm going to cancel like crazy. 3 goes into 15 5 times, 3 goes into 3 once, 4 goes into 4 once, 4 goes into 8 twice. 5 goes into 10 twice, 5 goes into 5 once, 2 goes into 2 once, 2 goes into 2 once. I got ones left everywhere, guys. My answer is 1. Turning the page in my math book, number 25. 25 says 1/8 plus 5/6 times 3/4. And I look to see what I can cancel. Divide by 3 is 1. Divide by 3 is 2. Multiply the top 5. Multiply the bottom 8. So now I have 5/8 plus 1/8 gives me 6/8. 6/8 reduces to 3/4. 27. Which is equivalent to 2 times 2, 2 squared times 2 to the third? Guys, remember when we multiply exponents, I'll just show that for you. This is 2 times 2 times 2 times 2 times 2. Well, how many 2's do I have? I have 5 of them. It's 2 to the 5th. So my answer is A. When I multiply exponents, I add the exponents. So 2 squared times 2 cubed is 2 to the 5th. I add exponents. That should be an add sign, add exponents. 27. I just did that one. 28. Arrange these numbers in order from least to greatest. So I have 0.365. I have 0.3575, and I have 0.36. Okay, I'm going to add zeros so they're all the same. And now I just look. This is 3,500. That's the smallest. So I have 3,575. This one is then 3,600. So that is 0.36. And the last one is up here at 0.365. And number 30, a bag contains 3 red, 4 white, and 5 blue marbles. If one marble is drawn from the bag, what's the probability that the marble will be all these colors? So step 1, 3 plus 4 plus 5 gives me 12. How many of them are red? 3 12s reduces to 1/4. My answer for A. How many are B, white? 4 12s reduces to 1/3. My answer for B. How many are blue? 5 12s can't be reduced. The answer for C. How many are green? 0. There are no green ones.